Okay, we're going to algebraically derive Kepler's third law, and to do so we need an understanding of universal gravity as well as an understanding of circular motion. We know from circular motion that the net centripetal force has to abide by this rule, F sub c equals mv squared over r, and we also know from universal gravity that the force between two objects of gravitational attraction is quantified by this equation. So let's take the hypothetical situation of a mass orbiting a planet. We'll have a little mass out here, and it's orbiting planet Earth at a distance of, we'll just call it r, between the Earth and the planet, or whatever mass it is. Now, if I did a free body force diagram on this mass, free body out here, I have this inward force of gravity. Now, we know from our understanding of circular motion that inwards forces minus outwards forces equals our net centripetal force, and that's where this equation comes from. So then, by the definition of what that means to be a net centripetal force, it looks like force of gravity is our net centripetal force. So therefore, our relationships mv squared over r has to be the same as the force of gravity between them. So I could say mv squared over r equals gmm over r squared. Now, the little m would represent the mass of the orbiting body. The big M would represent the large body of the planet. So those are on both sides, so they're going to cancel. Also, we've got an r on both sides, so that's going to cancel too. And then we're left with v squared equals divided by r. Well, let's manipulate that too. V, which is velocity, just means distance over time. So the distance traveled in one orbit, we'll assume is circular, 2 pi r, divided by the time it takes, period tau. All of that squared equals g mass over r. Well, I'm not done simplifying. I've got r's on both sides still. We can, well, first of all, let's square everything, and we get 4 pi squared r squared over tau squared equals g m divided by r. And we can multiply both sides by r to get rid of that r. And I'm just going to bring my work over here because I ran out of space. So I can say 4 pi squared r cubed equals, well, divided by gm equals tau squared. Look good? And so then I have a working relationship between the distance that something's orbiting from and the period of its revolution. So they're going to be proportional. They're going to be proportional by this factor, 4 pi squared over g times m. And from that, since they are proportional, I can say things like this. I can say tau squared over r cubed is equal to constant. So any tau and any r would equal the same constant, 4 pi squared over gm. And I put little subscript 1 because that means you can make relations between two different planets within the same system, like so. And that is Kepler's third law.